World War II. Well, World War II is a very fun and skill-based era in air combat, and he wants to recreate that for his game. But how can you explain the fact that these ships that have immensely more powerful engines are flying around without an atmosphere? How does that create a feeling of World War II? Obviously, it's very different. Well, he wants to use realistic physics, realistic Newtonian physics, but also have it feel like World War II. That seems like it wouldn't fit together, but we're going to explain to you why and how it does. So one of the main reasons that he gives in fiction for why all of these maneuvers in combat takes place at such a low velocity, such a low speed relative to each other, is the G-forces. G-force is a term often used in aerial combat to represent the physical acceleration of your body being pushed in a different direction, for example. The pull of gravity on Earth at sea level is known as 1G, or 9.8 meters per second per second. 2G is equal to twice the force of gravity at sea level, 3G is equal to 3 times the force of gravity, etc. Now, your body can tolerate only so much acceleration before you get a lot of detrimental effects. For example, if you're standing on a planet where gravity was equal to 10 Gs, your body would have a very difficult time pumping the blood back up to your head against the force of gravity, and you'd probably pass out. However, our bodies have different tolerances of G-forces in different directions. So the idea is these ships can only turn so fast without having a major detrimental effect on the body. That means that combat has to take place at a slow speed, or else people will basically be pancaked within their own ships. So that's the reason that combat takes place at such a low speed. But that is also going to affect the actual mechanics in the game. For example, your body can take a lot more positive Gs, which if you think of an aircraft and pulling up in an aircraft in order to make the nose go above the horizon, that's considered positive Gs. And our body can withstand many more positive Gs than it can negative Gs, which is tilting down, as in pointing your aircraft down towards the ground. And that is going to be an effect in Star Citizen. When you try to turn your craft, likely the best and most effective maneuver to turn your craft 180 degrees from where it's currently pointing is going to be to pull up on the stick, making it feel like a real aircraft, because the same forces that affect an airplane and dictate which direction it turns are in effect even though you're in space. It has also been mentioned that you will likely be able to turn off these safety features and try to ride the edge of your own character's tolerances in the game, so that maybe you can pull and turn just a little bit faster, but at the risk of potentially passing out at entirely the wrong time for 5 or 10 seconds. Okay, so that explains why combat is taking place at such a low speed, but how are you going to make it feel like atmospheric flight? I mean, there's no drag in space. There's no atmosphere to slow your plane down. You're not using the wings to actively turn your plane by carving through the air. So how do you reconcile a Newtonian physics and inertia with World War II aerial combat? Well, first of all, Chris said that the game uses actual physics-based thrust and vector calculations to determine how your ship moves. I'll quote directly from him here. Chris says, quote,
"And just to reiterate, the flight model and movement you have seen and will always see is 100% Newtonian. All movement of spaceships in gameplay is achieved by applying impulses to the rigid body of the spaceship, either to affect the linear velocity or the angular velocity. There is no cheating or fudging where we introduce fake drag or anything of that nature."
End quote. However, the ships will use their thrusters to try to simulate drag to make it fly more like a plane, or at least that's the default. There's something in your ship called the Intelligent Flight Control System, or IFCS, and that actually takes and translates the movements you make on your joystick or mouse into thrust calculations, and then has the maneuvering jets and the main thruster of your ship execute those calculations. So what in effect it's doing is trying to interpret the goal of what you're doing and get you there. You're not going to be controlling individual thrusters. You're going to say, I would like to have the ship roll to the left and then pull back on the stick and pull the nose around. And it's going to turn that input into a series of thrusts out of the maneuvering jets in order to get this effect that you're looking for. In addition, there's a piece of the intelligent flight control system that tries to simulate drag. It will constantly try to adjust your current vector, the direction in which your craft is moving, to be identical to your heading, where your craft is pointing. So if you're moving along at a certain sort of straight ahead, and then you sort of pull up on your stick so that your craft is now 90 degrees pointed straight up in comparison to your previous heading, the ship by default will fire all the thrusters on the bottom of your ship to slow you in your previous vector and try to have the main thruster push you up and start you going in your new vector. This is a sort of simulation of drag, and it tries to cancel out that inertia. But Chris has mentioned that depending upon how massive your spaceship is, you're going to feel a sort of delay. It's not going to be instant like a plane. Some of the faster dogfight craft are going to have more powerful maneuvering jets, allowing them to make these very fast plane-like maneuvers, but it's only because their maneuvering jets are able to cancel out their previous vector in order to have you carve through the air like a plane. Another thing to consider is that the IFCS can be adjusted and tinkered with and upgraded, and you could potentially have situations where you might want to turn off this simulated drag system. For example, to perform the so-called Battlestar Galactica maneuver, amongst others. For those unfamiliar, this would be where if you're flying straight and somebody's behind you on your tail shooting at you, you would then use your maneuvering jets to simply spin around 180 degrees. So now you are pointing directly at your opponent, but you're essentially flying backwards. Normally, the computer would try to slow you down and get you moving in the opposite direction, but it's going to be possible to turn off that function so that you could simply spin around 180 degrees and now you're flying backwards and shooting backward at your opponent. Some have pointed out that some of the thrusters model, the way it looks visually, doesn't look like it's applying the right thrust. Chris Roberts has addressed this directly, quote,
"The problem with visually depicting the proper thrust is that it would actually look pretty horrible. Trust me, this is how I first did it, and it's still pretty easy to switch back to as I'm actually doing some extra work to make the visuals look nicer. The reason is because there's no drag in space, so even a micro amount of thrust starts the spaceship rotating until you apply counter thrust. So what's really happening is that the flight control system is always applying these very small micro thrust and counter thrust to achieve the pilot's inputs. The result is the thrusters are flickering on and off in micro amounts, and you actually do not get a good feel of the general application of thrust just by visually looking at it. I think you know I like things to look cool. Come on, we all know you probably wouldn't be engaging in space dogfights at World War II speeds, but it's so much more fun than the reality probably would be. So what happens is the system is still modeled accurately, but I use the angular/linear velocity delta to drive the visual representation of the thrust."
End quote. So while the thrusters should technically be firing only in very, very micro small bursts, it doesn't look cool. Instead, they stay on as long as the ship is still turning in order to make it much easier to comprehend visually what's going on.